Hello, this is a live stream for Commodity Supply Chain Management. This is week 6 strategy. Let's bring up the syllabus to see where we are. And this week is strategy. And this is the last, the 5th topic and the last topic on the basics of supply chain. And then in strategy, we start pulling a lot of what we did together in the first 4 topics here. And then the last half of the course is when we're going to start applying them to different type of supply chains. And so today in strategy, if we come down here, we can see we're going to be covering 4 chapters that I've selected from the textbook that I think he spreads it out, because in pretty much every chapter he talks about strategy. But specific strategies in chapter 6, 11, 12, and 13, those seem to be more directed toward actual strategy. We're talking about the push-pull systems here, and then we go into lead time, demand. We go into the customer design and pricing strategies. And so he has a whole gamut from the source to the destination, from upstream to downstream. Okay, so let's pull up the website. Well, if we go to the Canvas, under course material, and down here under the website here, mdharper.com, under supply chain management tab, we come down to commodities here. We'll do these strategies 1, 2, 3, and 4, chapter 6, 11, 12, and 13. That's what we're doing today. So let's get into it. Let's open the first one here. Let's see here. I've already opened them. So let's start with the first one here, and that is chapter 6, push-pull strategies. Okay, first of all, in chapter 6, he talks about the push and pull system. A pull system really initially is looking at the demand, where it's dependent on actual or realized demand. You wait for the demand to happen and then you respond to it. And that's similar to a make-to-order operation. But actually, internally, in order for a system to support a pull strategy, it's dependent on the system status. In other words, the system status has to be tuned and primed and designed to respond to realized demand. So just having a pull system or pull strategy, it goes back up into the actual system. It's not necessarily with the demand. A push system is dependent on forecasted demand. So once you forecast the demand, you establish a system, and it's not really dependent on the system status. In other words, the demand is not. So you create your inventory, you create your operations in your system independent of the actual demand itself. It's just the realized demand. It's the forecasted demand. Now, the push-pull boundary is a position in the supply chain where the push and pull characteristics meet. You can have a push system upstream. You have a pull system downstream where they meet. That's the push-pull boundary. And usually within an organization, a company, you'll have a push-pull boundary. But in a supply chain, you can have these boundaries multiple places. Okay, factors in implementing a system strategy include demand uncertainty, economies of scale, lead time, complexity of the supply chain structure, and the focus of the enterprise. What's the mission, vision, value of the enterprise? And later today in this lecture, the focus of the enterprise also depends on the product and the customer. Okay. Characteristics of push-pull strategies right here. If we look at demand uncertainty, well, push, you have low demand uncertainty, you have very high certainty, very predictability, you can forecast your demand. And the high demand uncertainty, you have to wait for the realized demand because it's very volatile. Economies of scale, since you have low demand uncertainty, high dependence on economies of scale, then you can plan ahead. And usually this is longer lead times, again, higher inventory. Complex systems. Push system can hide a lot of the difficulties in designing complex system. In other words, large inventories with forecasted demand, you can accommodate more complex systems within your supply chain structure. And so the more complex the system is, the more complex your supply chain is, you'll move toward having inventory to cover up those inconsistencies with the details. Over here, you'll have high demand uncertainty, low dependence on economies of scale, simply because the you have volatile demand, and usually that's short lead times, and so you're not going to be building up inventory because you're not forecasting it. You're just responding to realized demand. And this works much better with simple systems, because then you're in control of the realized demand in the system. So therefore, a lot of the focus then with a push system is on cost, advanced planning because of the forecasted demand. And this is preferred, or you lean toward a push system, for which is referred to as efficient and lean supply chains. And we'll look at this in the second half of the course. We'll start with lean supply chains and efficient supply chains. On the service side, though, since you're responding to realized demand, short lead times, the service then becomes a focus with order fulfillment is the metric. And then those are flexible and responsive, or agile supply chain systems. And so we'll look at these kinds of systems. And so just because you choose a certain type of supply chain, as we'll see in the second half, it doesn't necessarily mean you should be doing that. And a lot of times it's not pure pull and pure push, it's a combination. And that's what we'll look at here. Okay, indications for push-pull strategies when you begin combining them. First of all, remember the push upstream. This is upstream for the supplier, downstream for the customer. If it's a short lead times downstream for the customer, that's the design. And then you have forecasted demand, low demand uncertainty. In other words, it's very consistent upstream. You know what you're going to have to supply upstream for the downstream demand. But downstream, the order fulfillment strategies is going to be short lead times, high order fulfillment. So therefore, you have a push system upstream because you can have advanced planning, and then pull system downstream for customer service or order fulfillment. So upstream push, downstream pull, and usually that has to do, since this is short lead times, has a this would support a continuous replenishment inventory strategy, where you have a lot of inventory upstream, but you don't have a lot of inventory downstream. You have it JIT, just in time, or pull system, so you have a continuous replenishment. The support for that would be point of sale and EDI, and we saw EDI last time. Indications for a pull push. Well, the push downstream is when you have longer lead times. Well, longer lead times are products downstream that have usually larger items. You can order something and you're willing to wait for it. Custom type products, you have to wait for that. But then upstream, you'll have a high demand uncertainty because you have a lot of variety in the product variety. And so therefore upstream, you'll have realized demand. You have to wait for that order to come in to make that. But you have long lead times because of that. You're going to have longer lead times down here. But the longer lead times then will be a push system, and the high demand uncertainty is a pull system. An example that was given here is going to be either the automobile industry, which you're going to have for customized automobiles, or furniture. So upstream pull and downstream push is inventory positioning, because you position, since the push is downstream, you position your inventory downstream. So therefore, if downstream the demand of the product variety changes between the different downstream areas, then you'll have positioned inventory. And that certainly happens when you have a national or global type of supply chain, because the demand varies. The demand for the different products vary. I know in commodities, if you have the textile industry, or in the agricultural or flour, you'll have different uses for flour in different parts of the supply chain. And so you'll have inventory positioning. Well, you have to wait for these orders to come upstream because each one has its own cycle and demand. So therefore, the demand upstream would be for the different commodity products then would be uncertain. So upstream production strategy is a pull. Downstream distribution strategy is a push system because of the inventory positioning. So therefore, you have strategic safety stock. This is supported by the strategic safety stock downstream that we saw back in inventory. Okay, therefore the indications for push-pull boundary is you have the push is the supply chain planning, and the pull is order fulfillment. These are what will be the focus. And down in the middle here is you have something called buffer inventory or safety stock, and this buffer inventory is the boundary between your supply chain planning and order fulfillment. And so this is integration using forecasted demand. So your boundary right here is where your buffer inventory is. You're buffering the push system between the push system and the pull system, and that's the integration for the forecasted demand and the realized demand. Okay. Now a little bit more, going a little bit deeper and looking at factors that drive this. Demand uncertainty, high is pull and low is push, but also economies of scale. Well, if you have low dependency on economies of scale, that's more of a pull system. So you're not going to have large inventories. It's going to be realized demand. Well, on this side, the low economies of scale is the computer and say books and CD. But why would demand uncertainty? How can you have a push low and and economies of scale pull? Because your demand uncertainty then quite often upstream could be more of a push. This is a push pull. Now here this is a pure pull, and then over here with a push system with a furniture and grocery, a pure push is grocery because your grocery, your supermarket is where you have all of your inventory. It's a push system and an inventory downstream. But then the pull push system up here is going to be like furniture, like we mentioned before, where the push system downstream is when you come to the warehouse, come to the showroom. Furniture or automobiles, you come to the showroom, there's the automobiles, there's your furniture, there's your couches and lounge recliners. That's what you want to buy, but the demand would vary, so therefore it's a pull system upstream because the demand varies in different parts of the country, different parts of the supply chain. Okay, but also you can talk about different demand uncertainties with lead time. And again, with a short lead time, that's a pull system. Okay, and so for the high demand uncertainty, a short lead time, that's a pure pull. A low demand uncertainty with a very long lead time, that's a pure push. But as we mentioned before above, here if you have a high demand uncertainty with a long lead time, well then you're going to have an inventory positioning downstream. On the other hand, if you have low demand uncertainty but you have a short lead time downstream, then you're going to have a push system upstream to create inventory, but then you have continuous replenishment downstream to support the downstream pull system. And so you can see how the supply chain can be designed depending on what the demand is, depending on what the lead time is, and depending on what the product variety is. So the different factors here for demand and lead time, push-pull strategies driven by demand and lead time that impact cost and service. Well, for lead time, the lower lead times traditionally support enhanced order fulfillment. Logically, because the lower lead times, you can satisfy the order quicker. But also because the lead times are shorter, it's usually enhanced customer service, and that leads you to a pull system. Greater lead times traditionally support enhanced economies of scale, because then you can have larger inventories and drive down the cost, lower cost, and that indicates a push system. Now, as far as demand is concerned, Aggregated demand lowers error through law of large numbers. Well, the larger when you aggregate demand, you have larger lot sizes and larger means. Well, the error in that decreases. So you're going to have a decreased error when you have aggregated demand. And we saw that with risk pooling. That lowers standard deviation. So therefore, enter demand forecast to support supply chains between stages. And so therefore, you can support between stage strategies when you aggregate demand. On the other hand, demand shaping or conditioning, but you can shape the demand, and we'll see later through, let's say, customer pricing and smart pricing, shaping your demand will lower the error through cause and effect that focuses on critical factors. So therefore, you can shape the demand through different, we saw last week, like everyday low prices or different type of strategies downstream with realized demand or forecast demand. Well, you can lower your error through demand shaping to make sure if it's going to be higher, you can shape your demand, and depending on how you design your pricing strategy and your supply chain strategy and availability. So intra forecast to support supply chain within stages. So this is demand shaping. A lot of times that is done within an organization, within an intra strategy. So you're balancing your supply and demand with supply chain strategies that can be addressed through e-business capabilities. Your e-commerce, e-procurement, e-fulfillment, e-business, etc. And so the internet can be key in balancing your supply and demand, okay, within supply chains. So that's push-pull. So now let's go a little bit, let's shift a little bit, and let's go to design for logistics. Now let's go to the logistics part. Okay, for the logistics in Chapter 11, they break this up into 4 different stages. The first is the design supply chain, that's the logistics, and the development chain, the logistics of developing the actual product. Example, push-pull would be a strategy, okay? Or you can design the material or design the processes, and there's where you design for logistics. Like, for example, design for logistics is packaging, and then the design for logistics could be supplier integration upstream, and then finally the design of the production would be, for example, as an example, mass production. These are just examples. There are other illustrations. Now notice we talk about the chain, material and processes, logistics, and then production. Okay. Well, first of all, the drivers over here. For supply chain, we've already seen this. The drivers for the supply chain is demand uncertainty, economies of scale, and lead time. Your demand, lead time, economies of scale for push-pull systems. But the development chain, which develops the actual product, the drivers, first of all, for the product technology clock speed, you have your introduction, project introduction, to where you have your innovative versus functional product. And so what's the clock speed? Is it an innovative product? Is it a functional product? So the development chain then needs to be coordinated with the supply chain. Or the make-buy decisions, outsourcing your decisions. Is it modular? Is it integral? Combined with knowledge and capacity? So therefore, how is it going to be coordinated with third parties, or RSP, or other types of alliances? And finally, and especially, the pandemic heightened the reliance on alliances because you needed to trust your upstream and downstream partners and partnerships. And finally, the product structure, your design for logistics, and we'll look at packaging, parallel processing, and standardization. And the packaging has to do with the product, parallel processing is the process, and standardization is the whole supply chain. And we'll look at that here toward the end here. Okay, first of all, in the supply chain, for the push-pull, which indicates push-pull, for demand uncertainty, high uncertainty indicates a pull system. Low uncertainty indicates a push system. So you see where your demand uncertainty is within your supply chain. Economies of scale, low dependence is a pull system. High dependence is a push system. So larger the inventories, the more you can rely on and depend on economies of scale to drive down the cost. Lead time. Short lead times is a pull system for order fulfillment, and long lead times usually indicate push system. Now, these are not strict, but these are characteristics that lead you toward push and pull. Okay, the development chain, modular, or innovative and functional, or modular and integral. For the clock speed, the innovative is fast clock speed. Innovative, it turns over very quickly. Functional is a slow clock speed. The design really doesn't change that much over time. The project variety, the innovative is high variety. Functional is low variety. In other words, you'll have a commodity, and that commodity really doesn't change over time. And then finally, profit margins are usually high because there's a lot of operations that go into the innovative products. But then the functional are fairly low profit margins because you have economies of scale, and you can drive down the cost. Okay, here's just some examples of a product design. You can have a fast clock speed modular, and here's some examples. Like the cell phones would be a push system because it's a fast clock speed, but it's modular. Okay, so even though it's fast, it's modular. Like cell phones, if it's push. If it's a pull, it's like fashion or personal computers. And so these are examples that were given for either low demand uncertainty for push, high demand uncertainty for pull, because things change very quickly. And cell phones, the uncertainty it's pretty consistent right now because of their design of their product offering. They tie you in. They'll tie you into an Apple. They tie you into an Android. Okay, then you have a slow and integral here, and so examples here is the furniture and tires under a pull system, and pasta diapers under a push system, because these don't change much, but it'd be more of a push system. So these are just examples, and so this is how you would put together a strategy for a specific product. Okay. Now, for design for logistics, there's a number of things here that are very popular today and are gaining in popularity. Well, first of all, the packaging. You design your dimensions to reduce space. Instead of having circular, you can have squares. That way you can pack more into a specific space. And design your product for delayed packaging to support cross-docking. In other words, your packaging can be modular, such that you can ship smaller parts, but then at the cross-docking, for example, if part A was made over here and part B was made over here, you package it such that it's very efficient shipping to the cross-dock, and then then it goes together easily to go to the final downstream destination. And so you can design your product for packaging to modularize it so that it can be support your cross-docking. It's easy to put together. It's easy to cross-dock it. Parallel processing. Well, here's you're taking a series function and making it parallel. Instead of doing things in series, you make it in parallel so it goes faster. Timing. And you decouple the process to support parallel functions. Now, when you have a process and you decouple the process, and you can start redesigning it. If you have the first one is processes in series, so you just do them in parallel. But the second one, you have a process, you redesign it to decouple the processes. So when you have it, then two things can happen. One is fast, speed. The other is quality control. Then you know what this does, you know what this does, you're separating it out. And so you have more visibility on the quality control of the processes. That gets into process design. And then standardization. Now, you aggregate demand to support risk pooling and economies of scale. In other words, when you risk pool, essentially you're standardizing your uncertainties. And you can create modularity. Create a modular product or a modular process, modular product, modular process to create advantages. Well, taking this last one and breaking it apart, a little bit more detail, the process can be modular, and the process can be not modular, and the product can be modular or not modular. So let's see here. Let's go down. Let's look at. Let's say the product is modular, but the process is not modular. So you can't break apart the process. That process will generate. It is a process. You can't modularize the process. The process generates each of the modules that go into the product. Well, that would be part standardization. So your standardization strategy then, if you have a modular product, but your process is not modular, it's one process, and that is part standardization. The idea there is you create your product design to have commonality. One product, one part or component can satisfy multiple products. And so you standardize a part such that it's common between all different products. We see it in the automobile industry. You'll have a certain product or a component within one car, one automobile. It's going to be the same in all the automobiles. Now sometimes it changes, but it's usually the windshield wipers are going to be the same across the board, or the glass or the windows, or the commodities especially. Next is process standardization. What if they're both modular? Well, the process is modular, but also the product is modular. So each product has modules, but each module, the process is modular. You can break it up. Well, now you have the maximum flexibility in producing that product. So when and where do you produce it? Well, here's where the strategy which people are using, which have used and using very efficiently and effectively today, is postponement or delayed differentiation of the product. Delayed product differentiation. And so the idea here is that upstream you have your commodities, and so you have modular commodities, the commodities that are modularized. Okay, but then as you go downstream, the final product here, you're going to have different modules within that product. Well, the commodities go into the different modules. But the processes do not have to be done in one place. It can be done up and down the supply chain. And so you delay the differentiation of the final product till the very end. So therefore, a product can have specific designs for each part of the downstream market, because you delay the differentiation of that product to the actual market. And so you postpone the actual product, design, the product differentiation to the final stage. An example of that is that you'll have power supplies and you have electronic components, and so the power supplies are made here, and they're modularized, and then the electrical the machine is done here, and you delay it, and you only put the final together at the very end. And so what you put together in Europe with their voltage requirements is very different than the United States with their voltage requirements. And so it becomes just as efficient with different products. And both are low cost, and the same supply chain supplies both of them. So you have standardization of the logistics until the very end, when you delay the differentiation of the product. And so you don't have to ship different products. You ship the same commodities and same primary commodities and secondary commodities. You ship the same ones, but then you delay the differentiation at the very end. So the process resequencing to support the postponement, you can resequence these processes to do that for the different end products. And the modularity of the products, also through resequencing of processes to support postponement. And so to support postponement and product differentiation, what you do is that you resequence the processes to modularize them, and then you redesign your products to modularize them in order to have postponement. So this is one of the more popular strategies of standardization. Okay, next is product standardization. What if the product is not modular, but they both are not modular? The process is not modular. In other words, it's just One process, one product, that's it. Well, that can be very costly if people don't want that. They want something a little bit different. So what they do, they have something called either super product design or downward substitution. They say, well, I'm going to make one product with one process and one product, one-to-one. So therefore, I'm going to design this product to satisfy a large number of needs. So it's going to really satisfy a lot of different products. It's called a super product design. It says, oh, I don't want that, I want this. Well, this product will do that. But I don't want that, I want this. It'll do that too. So it's a downward substitution, so that if you want something simple, you can buy this. Well, because you've standardized the product, then you can make economies of scale, the price strategic enough or competitive enough to where if you want something simple, you'll buy something which has much more capability. But because it's a super product, you have economies of scale that the price is close to what you would buy if you did it. It's like kind of like, do you want to fix something or do you just want to buy a new one? It's cheaper just to buy a new one because that new one will satisfy what you need fixed. And so that type of strategy is product standardization, essentially what it is. And finally, when you have a procurement down here, let's say the product is not modular, but the process is modular. So when you're making different products, but you have a modular process, then you can have equipment procurement to meet multiple internal process needs. So you have something called procurement standardization. Well, since the process is modular, well, then you can have different equipment to satisfy all different types of internal needs. So you have a modular process to satisfy different non-modular products. That's called procurement standardization, to procure equipment that will have that modular capability to satisfy different non-modular products. Okay, and so in some of the more specialized engineering type manufacturing areas, procurement standardization is pretty popular. I toured one time a company made trailers, and they made each trailer individually. The product was not modular; it was custom products for custom trailers for clients, customers, and so it was very costly. The cycle time was very, very large. And so what they did, they shut down operations and they standardized their procurement. And instead of having all these separate machines, they had one big machine, and it was an outlay. And it was a redesign of their process, and they modularized their process. So this machine could do all of it, but it was one machine that did it, but they did it more efficiently and quickly and high quality. So when they opened back up, that cycle time went from like 2 or 3 weeks to like 2 or 3 hours, and they could satisfy all the customized type product designs for all the different clients. And so they practice procurement standardization quite effectively. Okay. Finally, when you have an extended product system design, you can have something called mass customization. Well, 100, 200 years ago, production was craft. Craft was someone handmade your furniture. They handmade your clothing. It was craft production. And then at the beginning of last century, the Industrial Revolution, we had mass production. So this was customized design. This was more standardized design. Well, when you went to mass production, you had the same design because it was mass production, but you lower the cost. But the functionality was there, but the uniqueness was not there because of the craft. The craft no longer, the uniqueness of the craft was not there, but the functionality was there. So then what happened in the last part of last century is that you began to combine these two, something called mass customization. So the production became sophisticated technology became sophisticated, that you could not only mass produce them, but you can mass produce customized. And so you can shift with computer-aided design, computer-aided manufacturing. You can mass produce customized products. Well, the mass customization then increased your product variety for sure, and your service. Again, the cycle time was very short, and so therefore it decreased the cost because it was cheaper, and the time to market. And so mass customization, because of technology, basically didn't undermine either one of these. It combined them and supported each one. At least that's the, when mass customization is done correctly, then you do get what the craft element of customization and the mass production element of functionality, reliability, durability, and low cost. Okay, so where would these attributes be most effective in supporting mass customization? Well, first of all, it's instantaneous, it's very quick, it's costless. In other words, moving from one product to the next, it doesn't cost you anything. It's seamless. It's almost moving from one product design to the next. It's seamless and also frictionless. There is no wear and tear on moving from one to the other. So there is no loss of efficiencies. Okay, and so you have instantaneous is time, costless is monetary, seamless is design, and frictionless is the management and wear and tear maintenance. And so the idea is that mass customization is a extension of your product standardization. Okay, there's two good ones. The next one, go a little bit deeper into the customer. In other words, let's look at customer value. The customer itself, and then we'll go even deeper into pricing. But first, customer value. In customer value, we will focus initially on market mediation. And market mediation is conforming the supply chain to the product characteristics that create customer value. It's a focus on the customer. So you mediate the market with your supply chain to conform your supply chain to the market. So, market 5 dimensions of customer value. First, conformance to requirements, which is market mediation. Designing supply chain configurations, and we saw the different configurations. And your design for logistics, the DFL, we just saw that. The different supply chain configurations of your logistics configurations, and the DFL for design for logistics and standardization. You design those to conform to the customer value expectations. So now our goals are not just cost and service levels. We say, what is the customer expectations? Now we're including the customer into the supply chain strategy. So the lean supply chain focuses on cost, and there's where you have functional products. Responsive supply chain focuses on service, and there's where you have innovative products and short lead times. And so what type of customer expectations do you have? Are you moving to the low cost? Or are you moving to the agile or responsive supply chain? And we'll get into the different supply chains last half of the course. And then customer access will enhance customer experience on both of these. In other words, we're focusing on customer value. Well, the customer experience is the foundation of the value the customer perceives. And so we're looking at the perception and the expectations of the value to the customer within the supply chain. Next dimension of customer value is product selection, product variety, product selection. You can have the variety, but the product selection. In other words, coordinate product characteristics with supply chain characteristics. The product in the supply chain needs to be coordinated in order for the selection to be effective. For example, build to order, you can have manufacture to order, make to order, build to order, fabricate to order, assemble to order. Dell is build to order, so that it builds the system and then it delivers it. Automobile is inventory positioning downstream. Grocery is fixed product variety, because the product variety really, the variety of your products, the quantity really doesn't change that much over time. The demand may increase and decrease, but the mix of variety, it was not going to change in a grocery store because they're going to keep it the same. And that's why large chains have their own brands, because the actual demand for a product doesn't change that much. Maybe the brand of that product changes, but the actual product doesn't change. You're gonna buy bread, you're gonna buy milk, you're gonna buy cheese, you're gonna buy meat, or you're gonna buy grain, or you're gonna buy whatever. You're gonna buy that, and so therefore that product variety is pretty fixed. So there's product selection. Make sure you have a wide selection, and if the product selection decreases, the product variety decreases, then you have to replace that with another characteristic, say quality or customer service. The other is price and brand. The design the supply chain to maintain a cost and service to be competitive with little flexibility in price. So in other words, low price flexibility implies commodity product characteristics. Commodity product pricing implies more dependency on supply chain innovation. Now these two right here are important points. First of all, commodities, the characteristic of a commodity is that it doesn't matter where the source comes from. The source doesn't matter. In other words, it's called fungible. It's interchangeable. When you have electricity, electricity is electricity. Do you have good electricity, bad electricity? No, you have electricity. A lot of it is the supply chain. Is it there? Was it there in time? Is it continuously? Is it continuous in this service? So the actual pricing of it, usually the pricing for a commodity is low flexibility. In other words, a commodity is a price. Sometimes it's regulated, but the prices of agricultural commodities, of metal commodities, energy commodities, there's not a whole lot of flexibility in the price. So that implies a commodity. Well, commodity product pricing implies more dependency on supply chain innovation. And this right here is probably, now we're in the course where this really motivates why the commodity center needs supply chain, a course in supply chain, because commodity pricing, if the price isn't going to change, then where's your profit margin? Is on your cost. And the lower the cost, the more the profit margin, or the lower the cost, the lower the pricing. Well, if the price has low flexibility, you can't lower it that much, but you can lower your cost. Well, where's your cost in commodities? It's in the supply chain. So the supply chain and delivery, the delivery and the logistics is a large element of the cost of a supply chain, of a commodity. You have the upstream production of the commodity, but then the logistic of getting the commodity is a huge cost. If that becomes efficient, then the pricing strategy then can either be lowered or the profit margin goes up. And so a lot of the design within price and brand focuses on supply chain innovation to satisfy the demand efficiently and with low cost. And so this becomes a key factor in commodity supply chain management or in commodities. So supply chain is key in commodity management. Now, a greater price differentiation due to pricing of services implies less commodity characteristics. And internet can provide price differentiation due to service variability. So as the price differentiation becomes more important, it's less of a commodity characteristic. Now, some commodities, as you go downstream, as commodities are combined with other commodities, the price differentiation can grow as you change the character of a commodity into combined commodities. You can have a commodity, then combine it, then combine it. but then as the price differentiation grows, then it becomes less of a commodity, more of a marketable product. Well, upstream and downstream of a commodity and the final product, that internet can provide price differentiation due to service variability in the entire market, in the entire supply chain, upstream and downstream. So the internet, the visibility, the variability of services, and the efficiency of the internet, and also product variety, visibility, can impact price differentiation. And value-added services, not only price but also the services. Offering support and service as a strategy in addition to pricing is also a dimension of customer value. In other words, customer value, customer is a person or a persona, company, and so pricing is important to them, quality is important to them, and service is important to them. And so offering support and service as a strategy in addition to pricing addresses the humanity of the human nature of a customer. Commodity pricing leads to service differentiation in the market. Well, if the pricing is the same and the supply chain can lower the cost, but the supply chain efficiency can also impact service. So it not only has cost implication, it also has logistics and service implication and order fulfillment implications. And so commodity pricing focuses on the supply chain, not only for cost, but also for service. And that's why supply chain has cost and service as two primary objectives that you have a trade-off on. Services such as information access enhances customer experiences and control. Again, there's where the internet comes. Finally, relationship and experiences. Building customer and company relationships is part of the learning relationship. In other words, the learning relationship. Customer profiles that creates customer loyalty and unique customer experiences. The learning relationship is very interesting. It says, when a customer has a relationship with a company, this relationship should grow and they should learn. The company learns about the customer learns about the company, it grows. As you grow and you learn, that will create customer loyalty and commitment and ownership of an upstream supplier or a downstream customer. And so my customer or my supplier, that's what they're getting at. With a learning relationship is you learn how you cultivate that type of relationship. Okay, and then finally customer experience, and you can do that with the supply chain, because the supply chain not only is delivering your products, but it's gaining information and it's coordinating and it's creating relationships. So those relationships is not just to deliver goods or to collect revenue. It's to learn the customer, learn about the customer. Customer experience includes empowering the customer in the relationship. Let them make decisions, since if you can create an agile, responsive supply chain, then you can shift more power, decision-making power, to the customer, because you have the ability to respond to those decisions. And so the supply chain, an agile supply chain, lean supply chain, even a resilient supply chain, can impact the objectives of cost and service, but it can also impact empowering the customer. And so the more you empower the customer, the more you create loyalty between the customer and the company, because there's where the customer profiles come in. Okay, now the last strategy down here: price, product, service, access, relationship. All those are important, but which one do you pick? Which one becomes your strategy? The price, the service, the product itself has better than any other product, the access is immediate, or do you just look at your relationship? Which one's important? Well, The book has a very very good, Simke Levy has a very good strategy, is that you can't be good in all of them. You can't be good in everything. So you pick one that's appropriate, the right one, and you dominate in one of them. You're better than anyone else in one of them. Like, I have the lowest price. I have the best service. I have the best product. You dominate in one of them. But then you pick another one and you differentiate on another one. In other words, I have the lowest price and my service is not like any other. I do this and they don't. So it's not like you have a better service, but you differentiate yourself, because if you dominate in one, you differentiate in another, now you're creating a volume, you're creating space, you're creating more presence in the market. But all this will be ineffective if you're not adequate in all the rest of them. You can't be good at two and horrible at the rest. They say, I'm done. They'll leave you. So you don't mess up on anything. In other words, you're not bad at anything, but you can't be good at everything. You're dominating one, differentiate yourself in another, one or two more, but you're not horrible at anything. So you don't have to be good, you just don't want to be bad on any of them. And so it's adequate. You want to have adequate. You're not going to drive them away. Actually, flip that. If you are horrible at any one of these, that will drive them away, and that will eliminate the customer from your product. Okay, so you don't want to be horrible at any one, because if you are, that will drive them away. It just takes one. It just takes one bad experience here. On the other hand, if you're not horrible on any of them, but you dominate one, differentiate another, that's a good strategy. Okay, and these measures we won't look at measures, but we will talk about measures a little bit more later in the last half of the course. For the service level, you have lean supply chains based on the functional products as cost. Responsive is based on service, for innovative for short lead times. Customer access is experience. For customer satisfaction, you have surveys. Those are metrics. These are metrics for what I'm talking about here. These are metrics for service level. You say, how is cost a metric for service level? Well, you're servicing because this functional product is priced correctly. Okay, so lean supply chains can impact that. Responsive can impact short lead times, and customer access enhances the experience. So that service is important. Now, the satisfaction of the customer, you can measure that with surveys or measure it with retention and defectives. And finally, here I'm finally introducing the SCORE model, Supply Chain Operations Reference Model. Here's where you have different levels of metrics, and we'll see this in the last half of the course here. The SCORE model looks at different metrics, and we won't look at all of them. There's different levels that they have, level 1, 2, 3, and level 4, but level 3 is and they'll have hundreds of these metrics, and you don't use them all. You use what's appropriate for your supply chain, and that's why they have different levels, to create the framework and structure to know how to go in and use what metrics for your supply chain. So we'll do that later. Okay, the last, which is very interesting here, is customer pricing. Customer pricing, chapter 13. In customer pricing, you balance customer loyalty with your profit generation, and it's something called smart pricing. Okay, well, to look at smart pricing, we're looking at different types of disciplines or theories. First of all, the inverse relationship between price and demand. It has a very limited application. Now, as the price goes up, demand goes down. As the price goes down, demand goes up. That's true. but it's limited in its application. Now, demand conditioning or demand shaping can be used effectively through smart pricing. Now, we looked at this a little bit on everyday low pricing, but smart pricing, it's much bigger than that. There's a lot of things in smart pricing that can change, either shape the demand or condition the demand as you move forward. And finally, maintaining the objective of balancing customer loyalty with profit generation. You're always balancing that. And we'll look at that here in just a second. Okay. Well, we'll be evaluating smart pricing in three different developments. The first is price differentiation, which is part of smart pricing. Revenue management, briefly, more conceptual. And then finally, smart pricing directly. Okay, first, price differentiation. Now, price differentiation is varying your price, like markdowns, simply to capture market segments. And that is just the direct implication of the price-demand relationship. You lower the price to increase the demand, but price differentiation says, well, you can do that, but here I have a bunch of equations here. I just did this as a review. Down below here is where I actually describe it. Price differentiation. Here's the theory. Okay, here's the concept, and then down here's the mathematical development. Then I summarize this above. I'm not getting into the mathematics that much unless people want to. The point, well, I have it down here. You can look at it. The point is this. The theory says, well, there's a price-demand curve here. And notice this is a straight line. In reality, it's not straight. But anyway, let's say for conceptual purposes, it's a straight line. So this A here is the level of demand, is the amount of demand if the price is 0. If the price is 0, there's not going to be any demand for it. Nobody's going to buy it. I'm sorry. This price up here, for this price, the price is so high that the demand is 0. No one's going to buy it. But down here, at a 0 price, well, everyone's going to buy it. So this is the actual saturated market. A is the total demand. Okay, here is the top price, and here's the max demand. Okay, the demand can go from here down to 0. The price goes here down to 0. Well, the difference, let's say it's a straight line, just for conceptual, theoretical purposes. Well, if you lower, let's look at this price right here. If you lower the price here to this right here, well, the demand is going to increase. Well, this point right here, this is at this price in this demand level. Well, if this is the demand and this is the price, well, the price times the demand is going to be your revenue. Okay. Now, if I lower the price, then I'm going to increase my demand. But since I have this relationship here, the area then gets less. If I increase my price, if I increase my price, I'll decrease my demand. And this rectangle, the area is less. So there's an optimal price here which maximizes the revenue. Okay, so it goes from 0 and it goes up and it comes back down to 0 when the price goes from 0 to A over B. And so this inverse relationship, there's the equation, A minus B times your price. And so there's some optimal price here. What is that optimal price? Well, as it turns out, through the mathematics here, the price is 1/2, let's see, I have it down here, right here. The price is 1/2 A over B. In other words, halfway between. That's going to be your maximum revenue, theoretically. Okay, well, what if you wanted more than one price? Say, well, there's a lot of revenue here that I'm missing. So this triangle here, I'm missing that. I want to capture more of my revenue. Well, suppose you did that by having 2 prices. You had 2 different price levels, and once you once you have that demand, you go to the second price and get more of the demand. So some people will buy at the higher price and some people will not. You lower the price, the people who are not going to buy at the high demand will buy at the lower demand. So you capture more of the demand, so therefore you increase your revenue. Okay? And so the idea is if you have two prices, then where is the two prices between 0 and A over B? Well, down here I do that too, and as it turns out, it's 1/3 and 2/3. And so then the third one down here, I look at the generalization, and mathematically, if you have two prices, you divide it in thirds. You have 2/3 and 1/3. If you have three prices, you divide it in fourths. You have 3/4, 1/2, 1/4. And so the idea here is that you simply take, you decide what your maximum price is, what that max price is, maybe that's the manufacturing retail price, and then you say I can offer that, or actually the MLP suggested manufacturing retail price usually is less than that, down here somewhere, but that's going to maximize their revenue, not your revenue. And so what it is say from this price, what you pick as the highest price. Then if you want to discount it once or twice, you divide it equally between here. Now I notice I go into Targets and I notice that they have clearances, and they say okay, full price, and or you have a clearance 30% off. Okay, and if I want it, I say, oh, okay, I'll buy it. But if I don't buy it, I don't want it. It doesn't matter to me. I'm not part of that demand curve. And so I'll come in later. Well, it has final clearance, 70% off. Wow. Well, the price no longer is a factor. If you're going to buy it, you're going to buy it. If you're going to buy it at 70% off, you're going to buy it at 80 or 90% off. If you're going to buy it at 80, you're going to, that's that market, right? But what's 30? And then it goes away. So there's only two discounted prices, 30% and 70%. But what's 30%? Well, if you have two of them, that'd be 33 and 66. Well, 30 is 33% rounded to 30. 66, well, it's 70% with 66 rounded to 70. So they're doing the same thing at Targets or Walmart, or any type of store that looks at the general public. And so they're capturing the market who would pay full price. After time, when the sales go down, they discount to get the second tier market. When the demand goes down, they do it for 70% to get the third tier market. And they only do it 3 times. You can't do it too many times, because then you'll have the pennies disaster, where people expect discounts. They won't buy it at full price, 30%, 70%. They'll wait for the 90% discount, and they won't buy it. And so you have to be careful and know your customer bases. Well, that's product differentiation. Okay, then revenue management. Well, this is borrowed from the airline industry. Oh, this is just examples. You pick examples here. Now this is borrowed from the airline industry, and so this is not true in every industry. But because of the internet and the supply chain and things growing very rapidly, the concepts can still be used today in supply chains at a limited, in some higher scale than others. Okay, in other words, they have market segmentation, booking control, and network management, and the way they do that is they separate simplification. They separate out the market by 2 different travelers. You'll have the leisure traveler and the business traveler. Well, the sensitivity to price, leisure travelers are sensitive to price because it's out of their own pocket. Business travelers are low sensitive to price. They're not paying for it. The business is. Sensitivity to the trip duration, high sensitivity by the business travelers because they have to get there for that meeting. Low sensitivity for the trip duration for the travelers. Oh, I'm there, but I can stay another day. I'm on vacation, or yeah, I can wait a day. That's fine. they're flexible. Okay, the sensitivity to the duration of the trip, low, but it's high for travelers. And need for flexibility, very low. Need to be flexible for travelers, very high. Need for need for flexibility for business travelers, because the travelers need to be flexible, but the business travelers do not need to be. So they're highly sensitive to the flexibility. So they need to get there on time. In other words, I remember when I was in business, I would have a board meeting, and so I was in Denver, and say we had a board meeting in Los Angeles. Well, I would get up 5 in the morning or 6 in the morning and take a flight in the morning to LA in the morning, and then I would have the board meeting, let's say from 9 to 3 or 10 to 2 or 10 to 4, and then get on a plane and come back to Denver because I had meetings the next day. And so I'm very highly sensitive. That duration has to be very, it has to be in a day, and I don't have a lot of flexibility to getting there on time. I have to get there because I got to be there for the board meeting. I'm on the board, that type of thing. And you don't want them making decisions without you there. Okay. Anyway, so that they separate these things out, and it's truer now because with the internet you can identify people's sensitivity to price, sensitivity to duration, sensitivity to flexibility. Can you delay it a day or two? This kind of thing. Okay. Now, smart pricing. The last thing is smart pricing. There's two types: differential pricing and dynamic pricing. And so differential pricing is changing the price to sensitivity of market, price sensitivity of the market. And dynamic pricing is just a function of time. In other words, for market sensitivity, well, group pricing, say the different customers. So the example of different customers can have different prices. For example, senior citizens can have a discount, or military can have a discount. So different customers can have different prices. And so you encourage that. Next is different channels. Depending on the channels of sale. Well, if you buy through this website, you'll have a discount. Or order now. Call this number and you get a 50% discount. So different channels will provide different pricing strategies. Different regions. Well, here you have prices, let's say in the inner city, New York, Chicago, LA, Houston, might have a much higher price than Rifle, Muskogee, Bartlesville, Grand Rapids. So it might be very different in smaller cities or even rural cities, or even in Meeker, Colorado. The pricing may be very different because it's regional. Time-based differentiation over time. This time is different than this time. This time is just a function of time. This one is that the time-based differentiation is a function of time sensitivity. In other words, over time they'll become more sensitive or less sensitive to the market. Okay, product versioning here, the product design can really have a function of the pricing strategy. For example, you can design a product. Well, a simple example of this is that if you package it with gold or silver, you can ask the price can be higher than if you package it in brown or some dark color or something like that. So the packaging or the design of the product, or if it looks bigger, you'll pay more for it. If it's smaller, you pay less for it. If you have pictures on it, the design of the product itself could have impact on the pricing. And finally, coupons and rebates. That's the processes. The process of gaining a different price. Like you can have a smaller price if you use the coupon, but you have to bring in the coupon. So the process of getting the coupon, bringing it in, will change the price. Or rebates. You can have a lower price if you send off for this rebate from the manufacturer. And so the processes then could be a function of it. Now the dynamic price, this is differential pricing due to market sensitivity. The dynamic pricing here within the supply chain is specifically over time. Conditions to change the price over time. Well, when the production capacity is less than when the capacity is less than the demand, that's going to change the pricing. You have more demand, less capacity, the price is going up. Okay, increased demand over time. Increased demand uncertainty. Well, when the demand becomes more uncertain over time, that changes the price. When you increase the demand seasonality, well, seasonality means usually the demand is seasonal. First of all, the difference between uncertainty and variability. Seasonality is variability. It varies. It is very predictable. The seasons, the demand over the seasons will be very predictable. Okay? But what this increased demand seasonality means is that, well, this predictable variation of demand, the variability, could be greater. As it increases, then all of a sudden it has a strain on the supply side. Strain as the demand changes, the strain could have impact on the price. Now, uncertainty is not variability. Well, it is variability, but it's a different type of variability. Uncertainty, demand uncertainty means all of a sudden it's here and it's up there, maybe due to unknown causes, maybe anticipated causes that were unexpected, but anyway, it's uncertain. It jumps up and jumps down, and sometimes you don't know why it does it. Sometimes, oh, that's why I didn't expect that. Unexpected or unknown. And so that's demand uncertainty. When this happens too much, the price goes up because you have to respond to that uncertain demand. Short planning horizon. Well, if you have to respond quickly, a lot of times the price goes up. Low profit margins. If you want to lower the profit margins, you can lower the price. Okay, profit margins will have an impact on price over time. In other words, your demand price strategy again. So the dynamic pricing is over time. Okay, and so there's all different ways of changing your pricing. Okay, down here on the internet can certainly impact this smart pricing up here over time, because you have more access, faster access, and more complete access, and more detailed, granular access to the demand. The menu cost is like, it's almost online. Create a website, and all of a sudden you can maintain that website. And the ease of retailers to change pricing very, very quickly. You can change the menu very quickly. Just change it, change it, change it. So the cost of changing the menu online is very, very small. Lower buyer search price. In other words, the buyer, the customer can search very easily, cheaply. Does it really cost money to get on Amazon and look for something, to Google it? No. The ease and the lower buyer search will enhance your pricing. Okay. Visibility. You increase coordination through your supply chain for the logistics. Okay. Well, when you know exactly where your product is, sometimes that will impact the price of it because there's more cost, but also the visibility for the customer on important products where time is a critical factor. Then the visibility is important, and they're willing to pay for that. Customer segmentation. You create customer profiles. Some customers will pay more for certain things than others, and so you get to know your customer. The internet can do that, and the internet, with looking at your clicks, looking at the statistics, look at the data analytics, can create customer profiles. And finally, testing. This is a big one. You can say, I have a strategy, but on the internet you have real-time evaluations. Is this working or not? You don't have to wait a week or a month. You can see immediately or within a very short amount of time, is this really working or not? It doesn't seem to be working, so change it. It's easy to change it, and you can see, you can test different strategies in real time. Okay. So this really is an overview, a quick introduction to strategies from the push-pull, from the inventory, demand, lead time, to the different logistical designs, to design for the DFL, design for logistics, for the different development chain, to the customer value, to the pricing strategy, from upstream to downstream, the strategy in the supply chain. You can see, I hope you can appreciate the fact that supply chain management is not the same as operations management of just a product or a series of products within a company. Supply chain is much more complicated, much more, there's a lot more degrees of freedom. So therefore, strategy becomes much more important within the supply chain. And so this is all I have for today. And I'm going to post, I've already posted the homework online. And so I'm going to have, bringing back up the syllabus, I'm sorry, bringing, not the syllabus, bringing back up Canvas. Going back to Canvas here, notice down here, this is going to be rendered as a video. It's going to be posted right here as a video. I've been here an hour and 15 minutes, and so it'll be an hour and a quarter. And so, but notice the link here. I have a Zoom office hours Thursday at 7, Friday at 7, Saturday at 10 a.m. And that link right there will take it office hours during those times. And all my classes are there. It's not going to be recorded. It's just question and answer, just a conversation. So that link will take you there on those times this week. Okay, that's all I have for today. I appreciate you watching. This will be a video later today. And between now and the next time I see you, next week, let's bring back the syllabus. I mentioned this at the beginning. Next week, we're going to have review. And this review, I'm talking about the exam over 1 through 5 here. What to study, what to focus on. There's a lot of material. I'm not going to ask questions on everything. It's only on some of that material. Next week, I'll tell you how to study for that exam. Then you take the exam. Then we get into the different supply chains. And these supply chains here, then you start looking toward the project, because now we're getting into how you apply the different supply chains. Okay, that's all I have. Between now and the next time I see you, be careful out there. Take care of yourself. Stay healthy. Don't take anything for granted. Make sure you stay healthy so you can learn as much as you can in this opportunity that you have to learn. So between now and the next time, take care.